Welcome to Lecture 4, How Virtualization Works. In this lecture, we'll discuss how virtualization works. We know that virtualization works through the virtualization Let's start with the instruction set. An instruction set is a fundamental architectural component of a CPU. It is a list of all instructions with all their variations that a processor can execute. There are two types of instructions: non-privileged instructions and privileged instructions. The non-privileged instructions in an operating system. Examples of non-privileged instructions are add and sub that doesn't affect the state of the hardware. On the other hand, the privileged instructions are those instructions that change the allocation or state of the shared resources. Examples of privileged instructions include input-output instructions, timer The supervisor mode is also called as kernel mode or system mode. In the user mode, only non-privileged instructions can be executed, and this is the mode in which the user programs or applications run. When a user program needs to access an input-output device, it cannot execute the input-output instructions on the CPU as they are privileged instructions. So it has to request the service of the operating system by means of a system call to perform the privileged instructions. A system call is a signal sent by a user program to the operating system. x86 architectures have 4 levels of privilege called rings. Rings are numbered from 0 to 3. Ring 0 is the highest at ring 3 level. In a virtualized architecture, the virtualization software runs directly on the hardware in the supervisor mode and controls access instructions of the virtual machines are directly executed by the hardware, and this mode of execution is also referred to as direct execution. The virtual machines execute privileged instructions through its operating system, and these privileged instructions are trapped by the virtualization software, which emulates their execution through binary translation. Binary translation is an emulation of one instruction set by another through the translation of code. For example, if the virtual machines execute an input-output operation, the virtualization software has overhead. The combination of direct execution and binary translation is used in achieving the virtualization of x86 architecture. That brings us to the end of this lecture. In the next lecture, we'll look at why there's a need for virtualization in today's data centers. Thank you for watching.